Welcome to our new series. Our new series is going to be on synchronous management. It's based on the book Synchronous Management, Profit-Based Manufacturing for the 21st Century. And what we're going to do is really start looking at the principles that support the concept of synchronous management. So there's several principles that are touched on in the book. I'm going to take each one of them and discuss in a little bit more detail. The synchronous flow management that we're going to focus on today is don't focus on balancing capacities, focusing on synchronizing the flow. This is the first principle that's discussed in the book. And so let's get into what the details of what balancing capacities means and what does focusing on synchronous flow mean. If we look at a system is made up of different processes. Those processes do different elements of work as work flows through the system. And so if we look at this, the flow of work in this case flows from left to right, and it goes through different operations to complete the task. And then at the end of the completion of the task, the product or service is completed to ship to the customer. And we have a direction of flow. If we look at this balanced system, what does that mean? So it means that each of the resources have the same capacity. If I look at each resource has a capacity to do 100 units per day. If each resource has a capacity to do 100 units per day, what's the output of this system? So a lot of people would say, oh, it's 100 units per day. Well, it's not. Why isn't it 100 units per day? Because we have variation in the process also. So in any system, we have dependencies, which is resource 2 is dependent on resource 1, and each resource has a dependency in the system, but we also have variability. And every process has variability. So in this case, if we look at the efficiencies of each process 1 is 98% efficient, process 2 is 96, 3 is 94, 4 is 92. So what becomes the efficiency of this system? It's 98 times 96 times 94 times 92. So the system is only 81% efficient. So what's the output of this system? It's going to be 81 units or less. So that's what happens when we have a balanced system. If we have a balanced system, then we have variation. Then the output's never going to be what each person's capable of producing, because in a system like this, one phenomenon that happens is delays transfer downstream. So if Mona is going to have a delay, what's that's going to happen is going to cause Omar here to not produce because she couldn't pass on what she needed to Omar. And those delays transfer downstream. And another phenomenon that happens is gains never transfer. If someone has a good performance, the probability of that transferring to shipments is very small. So let's talk about synchronization. Synchronization is defined as a holistic business methodology that brings control and stability to an otherwise chaotic system. And when we look at it, it's created by synchronizing the system capacity to customer demand. And what does that mean? We only want to release work into the system to meet the demand within the replenishment cycle. So if you don't know what the replenishment cycle is, you can go back to my videos from previous sessions and understand what replenishment cycle is. But we only want to release work into the system within that replenishment cycle. Then to create the synchronization, we want to have unbalanced capacity. So unbalanced capacity means that each resource has different capacity. So if I look at the capacity of each person in this unbalanced system, you see they all have different capacities. And given the same flow direction and the same efficiencies, what's the output of this system? So again, we have the same efficiencies as the previous round. What's this system capable of producing? Well, by having an unbalanced capacity, what happens is delays don't transfer because I have sprint capacity or protective capacity if I utilize my resources correctly in the system. And so by having more capacity in the upfront operations than I do here at Omar, the chance of them causing delays for him goes down. And so now I can take Omar's efficiency times Steve's efficiency, 94 times 92, by decoupling the upstream operations and now the system can become more effective. So when I take those two efficiencies times the bottleneck resource of Omar 116, I actually get 100 units per day. So my demand rate is 100 units, and now I have the capability to produce those 100 units. So our lesson here is don't balance the system. We want the system unbalanced and synchronize the flow. So we want the pace setter or the bottleneck or the tax setter, whatever you call the resource with the least amount of capacity, to match our customer demand, given the variability in the system. That's our session for today. Next week's session, we're going to talk about the second principle of synchronous management. Focus on flow of the work and not the efficiency of the individual tasks, which will be a little bit more detailed of what we discussed today.